Salt is found all over the world. It is made of two components, one acid and one base. A positive ion from the base joins with a negative ion from the acid to create an ionic compound. But sometimes we don't want the positive and negative joined together. Sometimes we want these two components separated. The process of separation is called salt splitting. Okay, so let's look at what we have. You can use any salt for this, but we're going to use NaCl just for simplicity. So you have the half reactions for each one. The Na is going to be negative, the Cl is going to be positive. When you mix those together, you get sodium chloride, which is just your regular table salt. Now what's going to happen is that is going to be created into a brine solution. So a salt solution, which is going to go into this little setup here, this container. The basic construction of this is in the middle there's a bipolar membrane which is filled with water. This water is going to allow for the ions to be separated. On one side you have the anode, which is going to hold the cation. On the other side is the cathode, which is going to hold the anions. So your brine solution goes in here, and the ions are allowed to diffuse through the H2O. What happens is the cations go into the cationic membrane because they're drawn by the negative charge of the anode. The reverse happens on the cathode side. So now you have sodium and chloride separated into these respective containers. So what could be the application of this? Well, this process is actually used in mining. Instead of splitting sodium chloride though, it's ammonium sulfate. And this reduces the buildup of gas within the caverns, and the product can actually be used as a fertilizer, the ammonium sulfate, that is. Also, it's a process used in rivers to reduce chlorine levels by splitting the ions. Perhaps the best thing about salt splitting is that it's 100% eco-friendly. It's a process based on electrolysis, which is not environmentally harming at all. It can be used without harm to animals, without harm to humans, and without producing hazardous waste material. And here's a little fun chemistry fact. This man, William Lash Miller, was a Canadian-born scientist born in 1866. One of the areas he studied, along with biological sciences, was electrochemistry, and he was actually the one to study concentration changes and polarization during electrolysis, along with alternating and interrupted current.